Okay, in this tutorial we're going to just take a look at the lengths of a right triangle, and a right triangle being this triangle that has a 90-degree corner like this right here. Alright, so with that there are formulas that allow us to find the lengths of this hypotenuse and these two edges right in here. Now, hypotenuse is kind of one of those tricky words to spell, so just here's a good way to remember. It's really three words: hippo and ten and use, like that. And if you just remember that, then you always know how to spell it, because it's otherwise, yeah, it's tricky. Okay, so now in this case I'm still using a unit circle. Alright, here's my radius of 1 unit from here. Here's my y-axis right here. It's in green, you can barely see it, but it is. Alright, and then here's a 45-degree angle right in here for this triangle right in here, like that. There's my little angle like this. So there's 45 degrees that makes with the x-axis down here. And then we know from the previous lesson when we were doing the calculations of the sine and the cosine that if you took the sine of 45 degrees you would get this length along here, or the opposite side, and if you took the cosine you would get this length along here. So the cosine of 45 degrees would give you this length. Alright, so when you have these two lengths you can then calculate this length here. Well, for now, since we know this is a unit circle, meaning this has a radius of 1, then this length of the hypotenuse also has a radius of 1. Alright, so if we were to just say, I'll just get the regular calculator. We don't really need it, and I'll show you that at a later time. But if I was just to we'll just use 45 degrees and take the sine. There it is. We'll just use 0.7071 for this length along here. In fact, maybe I'll just do it like this, like that, and then this length here is going to be the same down here. Alright, so that's also the sine, and this is the cosine. Okay, so then to find the hypotenuse, then it's a straightforward formula. Formula for carrying around is a squared, and these are usually in italics, a squared like this, plus b squared is equal to c squared. Alright, and so what this is going to be your side of the triangle. Here's the angle A, and the opposite side of the angle is going to be this. There's A there for that length, and this is going to be B here for this length. These are in italics. And then this is going to be C up in here, like that. That's typically how you label them. So the formula is saying that you take this length and you square it, you take this length and you square it, and it's equal to c squared. So let's actually go through it, because this can be tricky if you're not super comfortable with algebra even, and we could have a wide range audience here, right? So we might as well just step through it a step at a time. So that is going to be the same as 0.7071 squared plus 0.7071 squared is equal to c squared. So for some of you, I know getting rid of this squared term, because we're trying to solve for c now. We want to basically isolate c all by itself to find out what this length c is for the hypotenuse. Even though we know it's 1, we got to verify it. Alright, so the way you do it is you first go here and you do these squared terms. So it's 0.70, here it is already on the calculator, 0.7071, and I'll square it with the x squared button, and the answer is 0.5. So this becomes 0.5 plus, and the same thing for this one, 0.5 is equal to c squared. So that still doesn't give me the answer. So because what that tells me is that if I add these together, 0.5 and 0.5 is equal to 1, and now we're saying 1 is equal to c squared. But how do I get rid of that squared term like this? Alright, because I'm trying to find what c is, not what c squared is. So when you have something like that, to get rid of a squared term you have to just take the square root of both sides. So I take the square root of c squared and I take the square root of 1, like that. And when I take the square root of c squared, it just becomes c. Because you can imagine, just like when we were doing the area and the volume measurements, when you multiply something like a variable times a variable. So if I multiply c times c, it becomes c squared. If I take the square root of c squared, it becomes c. And when I take the square root of 1, it just becomes 1. because 1 times 1 is equal to 1. Square root of 1 is 1. So C is 1. So there's our answer. C is 1. And that means our answer for our hypotenuse is 1 up in here. So this length along here is 1, which we happen to know is the same as the radial distance. These are powerful tools, and they allow you to calculate all kinds of things. And even if you can even, if you have a different, say, length hypotenuse, you can, and you know angles or other lengths, you can find other lengths, so you can kind of work back and forth between the two. And it's a really powerful tool to use. Alright, well that's it for now, and then we'll just continue on with this in the next lesson, and we'll cover these basics and really get them solid, because they're really important for the future, for all of you future math lessons and physics and things like that. Alright, and I'll see you then.